question? You have to read it from the page. I see you last page.
Wait, what page?
So it's page 3 of your document, I think?
From yesterday?
No, from today. in your reading section, that question.
That says teacher assisted notes. Right?
Yes.
Okay. In the circuit shown on page 763, diagram at the top of the page, the electromotive force EMF of the battery is 14.6 volts, and each resistor has a resistance of 473.55 ohms. Find the current supplied by the current to this circuit.
Okay, you got 10 points. You got to add it to where you put your points at. Oh, okay. Good job. All right, so again, we're going to investigate this circuit now mathematically. We saw it visually. It's still up there. You know, we like, I'm going to do point the camera here for a second. But it's still the circuit we're working on. I just added some things. 1 battery, 2. I get it. Not really light bulb in this one. I get it, but I wanted to make it interesting for y'all. All right, now, we're going to now calculate what Ms. Velez talked about. And I suggest you open up your book to page 762. Now, what does that mean? You still need these notes. You did yesterday. You can open up yesterday's document and copy your things. I gotta make things easy for you. So I'm gonna leave it here, but this is yesterday's notes. At least the tools you're using today. All right? Keep that in mind. Now, this problem, it incorporates fractions more than anything, because we have to calculate all of them. So try to keep up with me. So go real quick. When you're calculating your own, you'll confuse things if you miss the steps. Right? So with that said, let's set up our known unknowns. Again, you have this from yesterday. But it's a start for today's notes. You can go and type it in, or you can go to the previous document and just put it back in. All right, so what do we need? Let's see, what do we know?
Yes.
Versus unknown. What are we looking for, right? So let's try to figure out some values, right? Well, she said one important thing that I saw earlier, and that's the electromotive force, EMF, also known as epsilon, also known as your battery power. So that would be 14.6 volts. So epsilon, not E and not 3. You have to look at the Greek letter epsilon. That's how you spell it over there. We talked about this yesterday. Please don't put no big fat E's or 3's in here. I will subtract points every time I see it. All right, 14.6. No. Next, what else did they give us? Well, think about it. R is just the same for all resistors in the circuit. You might go to Apple and be like, how do you so it says each resistor, that's why I say it. So we're going to call it R, because all the resistors are the same. And that's 473.55 omega. So we're going to call it big R for resistor value of all. It's equivalent to, what do we say, 473.55 omega, right? And then the only thing we're looking for now is what you saw on your ammeter in that circuit. Well, one of them. Probably that one right there by the battery power, that ammeter, right? But we got to collapse the circuit mathematically before we can find that total current. So let's go ahead and mark that out as, hey, I'm being asked for I total. Which is equal to some number in amps, right? Now I can start working on the problem. I have all my ingredients out there for the problem. This is why you should do this first when you're doing physics or even math. You set up the known values, right? Because this physics technique works for just basic math too. Now we got that, we can work with what we have and solve for what we need. So let's go ahead and walk through this. So step one, what do you do, right? If you're looking at it, we have to find what is called REQ lower. What is REQ lower? I'm going to show you real quick what that means, right? And REQ lower is going to be based upon all of these branches. So here, REQ lower is going to be pretty much this part out here and this part out here. 28 parallel circuit equations. We're going to snap them together mathematically. All right, now, to do that, you got to write an equation that combines the first branch. The first branch has, what's called lower, 2 resistors. So we're going to write it out. Step 1, solve for REQ lower. You subscripted, y'all know how to do that, right? If you don't know how to write it, look at page 763. I'm on step solution 1. You don't know how to write that. You write it the same way. Is equal to, we got 2 resistors in that branch here, right? So that means we have to do for REQ lower, which is equal to R, right? We call it R plus R. But there's 2 resistors there. You see that first one by the voltmeter. We're snapping them together, which means you'll have pretty much mathematically 2R. Right? Everybody see how that happened? That's using a series, right? You might have forgotten about it for a series circuit. And you want EQ equivalent resistance. You don't have to write this, but it's just in case you don't understand. You have REQ is equal to R1 plus R2, so and so forth.
This one.
Right? That's the pass. This series. That's all I did there. Forgot, and go back and check your book. When you're doing parallel, you use this series, you use that. You look around that branch, you resist that series. You snap them together. So, all right, let's keep going because I'm looking at this clock. 1, 2, 3, 4. All right, we're almost through with this. Next, we got to figure out how to put the 2 parallel branches together mathematically. So we got to use our old friend here, right? And all we're going to say is, hey, to find a real REQ value, this is the step, and these are notes. So step 2, you got to solve for REQ, now REQ lower. A little different, right? So to do that, we're taking both those branches and using our parallel equivalent resistance calculation. As engineers and scientists, it must happen. So we say 1 over REQ, right? Just doing this. Is equivalent to 1 over, now keep in mind, we combined our series, so that's going to be 2R there. And then we have 1 resistor in that last branch, the very last branch by the volt. So we're going to say 1 over R plus 1 over 2R, which comes from this here. Okay? So y'all know these are steps. Now you know we get 2R from. After that, you got to do some basic calculations, elementary calculations of actual fractions. So that gives us, when you put this together, like term, not like term, but least common denominator, when you do all that math, what happens is you end up with, if you look here, 3 halves, right? So 3 halves, and then R. Okay? I'm sorry, 3 over 2R. 3 over 2R. That's just doing at least common denominator, right? So we don't have REQ, right? So we got to flip it. Now here's a math technique that you flip. You do the inverse of it. So to do that, let's write it again. This is the step. You say, hey, let's do some algebra real quick. And when I'm just taking this part here, so put parentheses around it and do that algebra trick I showed you to get REQ last time, right? If you don't see it, we can flesh it out for you. The book won't show you. But I have to show you. Because those are the questions students ask me. And they're good questions. They don't show y'all everything in these books. That's why I focus on it. So I'm doing this again, right? So this is an SAT trick, believe it or not. Put parentheses around that and raise it to -1. Because we want RQ, not 1 over RQ. So let's raise to negative 1. Once you do to one side, you have to do the other. Do you want some apples over there?
Right there. Okay, put the cursor right here.
So this allows you to flip those fractions. It's a step they don't show you in the book.
And the image. And then, of course,
So next, what do you need?
and
You
then
need a
check
chair.
this.
What do you want
Check
people
both
on?
of those. And then
We're almost through. We're almost through, y'all. Let me just clap. We got time to do all this work. So once we do that, this now becomes REQ. That's what we need. It's equal to 2, right? So you put the whole fraction. It's going to be 2/3 R. So R is in the bottom too. So you say 2/3 times R. That allows us to get our Q now, and then finally get our total.
Yeah, that's
So,
the first, yeah. Because you gotta
we
put
did
the-
that.
So don't worry about that. Huh? Which one?
So now, next, call this step 3.
Where it says, I think everything in those squares versus the
Solve.
resistance, yeah, you gotta put all of that in there.
For I total.
Yeah, and I can
So to solve for I total, we got to use our trusty string over here, Ohm's law, in terms of electromotive force. So epsilon is all, right? So let's do that, and then we're done. Well, numbers in, that's it. So that was a lot of algebra for you to get to the numbers, right? Anyway, so let's rewrite this equation here. We have epsilon, or electromotive force, is equal to I total. We get it from over there, y'all. I told you we're going to have to use both. Multiplied by RQ, which we just figured out.
What am I supposed to do next though?
And then epsilon, write it again, we gotta get epsilon,
just by itself?
not epsilon, I total by itself. So this is without,
I think it's the epsilon.
so that's gonna be, what are we gonna move? RQ, because I total is what we want. And I'm just gonna divide by what I know next to RQ. Cross that out, rewrite it, put the numbers in, we'll have a dessert, right? Or in y'all case, do some, you do some extra. So, what do we end up with at the end? Well, we know I total is equal to, rewriting our new equation, epsilon over your RQ. Next, we plug in our numbers. So that means epsilon here is going to be 14.6 volts, right? Divided by, not R, but RQ, right? So, we got to calculate this, y'all. This is a step right here. That's not RQ, right? I didn't put the calculator on.
I mean, which part you want? Where? On the
2/3
blue or oh, the R.
times, yeah, with R. That's step we missed. 473. I'm making a change here, y'all. I missed a step. And this RQ is going to be, I just put the number in. That's all I did. So we can calculate that. Grab a tab, quick. So that's equal to, you want to calculate it. You have parentheses 2 over 3, close parentheses, multiplied by, you have 473.55.
Go ahead and pick which one. And then once
That
you
gives
pick
you,
it,
that's
I
how,
think there's
of 315.7.
Then,
I guess I'll put 0
try
there,
to do the arrow.
omega, right? That's the real RQ value, ladies and gentlemen. That allows us to take this over here and finish the problem.
This one. Okay, oh, it's called omega. So you take it omega, so it's O M.
So, what is I total? Well, let's calculate it all down. Almost through.
This way over. You'll see it. Yeah. It looks like it's
So that'll be 14.6. 14.6 divided by 315.7.
So once you click on it, should be good.
And the final answer is 0.0, let's say 46.
And then you just
And that's this, in fact, ladies and gentlemen, final answer is the calculation for, move this such a way so you see it. And I'm done talking about it, because y'all got to get ready to pack it up. This is the calculation that you would get here. All these circuits will become one and one side circuit, And the calculations I just made will be from this current get in here so you can see what's happening in your circuit. All right, so you need all steps. I will take a picture. Eli, you got, I want to say 40 points, because that's a lengthy problem.